Assalamu alaikum. So today we will discuss about salts and identification of ions and gases. As we have different gases such as oxygen, chlorine and many other around us. So how we identify these gases and different types of ions. So today we will discuss about the salts and identifications of ions and gases. So let's start this class without wasting time.
Assalamu alaikum. So today we'll discuss about the salts and identifications of ions and gases. How we identify ions and gases. As in our title, a word salt is used. So the first question rises is that what is a salt? What is a salt? A salt is a substance formed when the hydrogen of an acid is partially or completely replaced by a metal. What is a salt? A salt is a substance formed when the hydrogen of an acid. For example, in HCl, when this hydrogen is replaced by any metal, then the salt would form. Whenever the hydrogen of an acid is replaced by a metal, then a salt will form. For example, a sodium is replacing hydrogen in HCl and NaCl form. This is a salt. So a salt, I can repeat what is a salt. A salt is a substance formed when the hydrogen of an acid, is partially or completely replaced by a metal. Now we will discuss the identification of ions. Salts are ionic substances, as in a salt, for example NaCl, there is a non-metal and a metal. So this is, I can use another sheet. What is ionic substances? For ionic substances are those in which there is a bond between a metal and a non-metal. Bond between metal and a non-metal. For example, NaCl. In NaCl, a metal is bound with a non-metal. So this bonding is ionic bonding, or this is an ionic substance. What is an ionic substance? Ionic substance is in which there is a bond between a metal and a non-metal. So salts are ionic substances and are therefore made up of a cation and anion. It's mean to say, in there is a metal and non-metal, there are negative charge and positive charge, because metals are positively charged and non-metals are negatively charged. So the salts are ionic substances, therefore they are made up of a cation and an anion. Cations are positively charged metal ions. They travel to cathode. Cations are positively charged, so they travel to cathode during electrolysis, because cathode is negative electrode, as opposite charges attract each other. So the positive charges, mean cations, would move to cathode, and anions are negatively charged ions. They travel to anode during electrolysis, because anode is positively charged. I can show you this diagram. In this diagram, you can see that there is an anode and a cathode, and the cathode is negatively charged and anode is positively charged. So the cations would travel to cathode, because cathode is negatively charged and cations are positively charged. So the opposite charges attract each other, and anions travels to anode. Anions would travel to anode because both anode and anions had opposite charges. So opposite charges would attract each other. So now we'll discuss the tests for cations, positively charged ions. The test for positively charged ions. Cations can be identified by their reaction with aqueous sodium hydroxide. NaOH. In aqueous form, then it is reacted with aqueous cations, then we can identify the cations, and by reaction with aqueous ammonia, and as a result they form different colored precipitate. From the precipitate we can identify the cation, which may or may not dissolve in excess alkali, which will show us the presence of any cation. For example, calcium does not dissolve in excess, but you can take zinc, it dissolves in excess, so we can identify by their dissolving in excess or they are not dissolving in excess. So the cations can be identified by the reaction with aqueous sodium hydroxide and by the reaction with aqueous ammonium. Now we can discuss various tests for various cations being positively charged ions. First of all, we'll discuss about ammonium. In few drops of NaOH, white PPT formed by aluminium, and in excess PPT would dissolve and would turn colorless. Aluminium would, in few drops of NaOH, they forms a white precipitate, and in excess, when excess NaOH is added to aluminium, then the aluminium will dissolve in NaOH and would turn colorless. What is the reaction with ammonia of aluminium? When a few drops, 5 drops you can take, are if added, it would form white PPT. Same would occur in ammonia reaction. However, in excess PPT, in excess ammonia, the PPT would be insoluble, they would not dissolve in excess. So I can repeat the test for aluminium. For aluminium, add a few drops of NaOH and white PPT form. In excess NaOH, the PPT would dissolve and turn colorless. And in the when the aluminium is added to few drops of about 5 drops of ammonia, the white PPT would form, and in excess the PPT would not dissolve. For calcium, in few drops of NaOH, this cation, calcium, would form white PPT. However, in excess it would not dissolve, or it is insoluble. For calcium, when a few drops of NaOH are added, the cation, this Ca2 positive would form white PPT. However, in excess it is insoluble. And in ammonia, calcium has no reaction with ammonia. So now we can discuss about copper. In copper, when a few drops of NaOH are added, blue PPT formed. The color of the PPT formed when few drops of NaOH are added is blue. However, in excess, PPT would be insoluble. In excess, the PPT are insoluble. And the reaction with ammonia, when the few drops of ammonia are added, blue PPT form, and in excess the PPT would dissolve and turn deep blue, mean the color of the PPT would dark or turns to deep blue. I can repeat the test is for copper. And if a few drops of NaOH are added, the blue PPT would form. However, in excess, the PPT would be insoluble. In ammonia reaction, the blue PPT would form, and if excess ammonia is added to copper, the PPT would dissolve and would turn deep blue. Now we will discuss the iron Fe. When a few drops of NaOH are added to Fe2 positive, dirty green PPT would form. And when excess NaOH would be added to iron Fe2 positive, the PPT would not dissolve, or it's insoluble. And in the reaction with ammonia, same would occur, mean the dirty green PPT would form in few drops. However, in excess the PPT would be insoluble. the test for iron Fe3. If a few drops of NaOH is added, means sodium hydroxide is added to Fe3 positive, the red-brown PPT would form in few drops, and in excess PPT would be insoluble. And when ammonia, the test for iron Fe3 with ammonia, if a few drops of ammonia are added, the red-brown PPT would form, and when the excess ammonia is added, the PPT would be insoluble. Now we'll discuss about lead Pb2 positive. When a few drops of NaOH are added, white PPT would be formed in few drops, and in excess PPT would dissolve and turn colorless. In few drops of NaOH, white PPT form, and in excess the PPT would dissolve and turn colorless. When a few drops of ammonia are added to lead, then the white PPT would form. However, when excess ammonia is added to the lead Pb2 positive, PPT would be insoluble. I can repeat for lead, when a few drops of NaOH are added, the white PPT would be formed in few drops. However, in excess, the PPT would dissolve and turn colorless. And for the lead, when the few drops of ammonia are added to the lead, the white PPT would be formed. However, when the excess ammonia is added to the lead, the PPT would be insoluble. Now we will discuss about zinc Zn2 positive. When a few drops of NaOH, sodium hydroxide, are added to the zinc, white PPT would be formed in few drops. However, when the excess PPT, means the excess NaOH, sodium hydroxide, is added to the zinc, the PPT would dissolve and turn colorless. And when the few drops of ammonia are added to the zinc, the white PPT would form. In excess, when the excess ammonia is added to the zinc, the PPT would dissolve and turn colorless. The PPT would dissolve and turn colorless. I can repeat the test for the zinc. In the zinc, when a few drops of NaOH are added, the white PPT would form. However, when the excess NaOH, sodium hydroxide, is added to the zinc, the PPT would dissolve and turn colorless. And when the few drops of ammonia are added, the white PPT would form, and when the excess ammonia is added, the PPT would dissolve and turn colorless. And now we'll discuss the test for ammonia. The ammonia, first of all, has no reaction with ammonia, aqueous ammonia. There is no reaction of ammonium with ammonia. So the ammonium has only reaction with NaOH, sodium hydroxide. Ammonia gas is produced on warming with dilute sodium hydroxide. When the dilute sodium hydroxide is added and it is warmed, the ammonia gas is given off. This is the test for the ammonium ion. Now we will detect ammonia gas. This gas has a pungent smell. First of all, if you feel the pungent smell, that means ammonia gas is produced, so this ion would be ammonium. And when the moist red litmus paper turns blue, when the moist red litmus paper is brought near to the ammonia gas, the paper would turn blue. This is the test for ammonium. I can repeat the test for ammonium. Ammonia gas is produced on warming with dilute sodium hydroxide. This gas has a pungent smell, ammonia gas has a pungent smell and turns red litmus paper blue. Moist red litmus paper blue. So now we will discuss about the test for anions. Negative ions. The test for negative ions. First we'll discuss about the positive ions. Now we'll discuss the tests for negative ions, anions. So the tests for anions that we will discuss are nitrates, carbonates, chloride, iodine and sulfate. So First of all, the aqueous anion should be there, should have the test. And first of all, we'll discuss about nitrates. NO3 negative. Add dilute sodium hydroxide NaOH and aluminium powder. For the test for nitrates ion, we have to add NaOH, dilute NaOH means dilute sodium hydroxide and aluminium powder. What we will observe, if a nitrate is present, ammonia gas is produced. The same as in the ammonium ion, the ammonia gas was produced. Same in the nitrates ions, the ammonia gas is produced. Now we have to detect ammonia gas. This gas can be identified as it turns red litmus paper, moist red litmus paper blue and had the pungent smell. So I can repeat this as for the nitrates. For nitrates, add dilute sodium hydroxide and aluminium powder, and observation is that if a nitrate is present, ammonia gas is produced. This gas has a pungent smell and turns moist red litmus paper blue. Now we'll discuss the carbonates. For the carbonates, add dilute hydrochloric acid HCl. Add dilute HCl hydrochloric acid. If the carbonate is present, carbon dioxide is given off. This gas turns lime water milky. When the HCl dilute hydrochloric acid is added to carbonate, carbon dioxide gas is given off. Now we detect carbon dioxide. As this gas passes from lime water, it turns lime water milky. If the lime water turns milky, there is a carbon dioxide, and if there is a carbon dioxide, this ion is carbonate. So now we will discuss about chloride, Cl negative. For chloride, add dilute nitric acid and silver nitrate solution. Add dilute nitric acid and silver nitrate solution for chloride ions. And observation is that if Cl ion chloride ion would be present, white PPT would form. White PPT would form if chloride ions are present in the solution. I can repeat this test for chloride ions. For chloride ions, add dilute nitric acid, and silver nitrate. And observation is that if chloride ion is present, then the white PPT form, because when the dilute nitric acid and silver nitrates are added to chloride ion, the result is that silver chloride is formed, that is a salt that is of white PPT. That's why there are white PPT, because AgCl means silver chloride is formed as a result of this adding dilute nitric acid to chloride. I can write the equation that is involved. Ag positive plus Cl negative when joined, AgCl is formed, and this is of white color. This is of white color. That's why white PPT are formed. Now we will discuss about iodide anions. So add dilute nitric acid and lead nitrate. For the test for iodide, add dilute nitric acid and lead nitrate solution. If the iodide is present, then the yellow PPT form. Same occur here. Pb and iodine combine together and form lead iodide, and lead iodide has the yellow PPT. Because of lead iodide, yellow PPT forms. So the test for iodide is that add dilute nitric acid and lead nitrate solution. If iodide is present, then yellow PPT would form. So now we'll discuss about sulfate ions. SO negative 2 4 Add dilute for the sulfate ions, add dilute nitric acid and barium nitrate solution. Add dilute nitric acid and barium nitrate solution, and white observation is that white PPT form, because as when the dilute nitric acid and barium nitrate are added to the sulfate, the result is that the barium sulfate is formed, and that have white PPT. So the observation is that white PPT form when the dilute nitric acid and barium nitrate is added to the sulfate. So these were the tests for the anions. First of all, we discuss about cations, and now we discuss about ions. Now we will discuss about the identifications of gases, the test for identification of gases. So first of all, we will discuss about ammonia, NH3. For ammonia, use damp red litmus paper. It would turn blue. Sorry, I have written here wrong. Use damp red litmus paper. The litmus paper turns blue. It's not red. It would turn. I can write here. I can cut it and write. It would turn blue. I cannot write it accurately, sorry. So for the ammonia, use damp red litmus paper. The litmus paper would turn blue. If the ammonia gas is present, then the litmus paper would turn blue. So the test for ammonia is that use damp red litmus paper. The litmus paper turns blue. Now we'll discuss about carbon dioxide. As we have discussed before, that when the carbon dioxide is bubbled through lime water, the lime water turns milky. When the carbon dioxide is passed through the lime water turns milky. So when the lime water turns milky, means carbon dioxide is present. So the test for the gas is that bubble through the lime water, and the result is that lime water turns milky. So now we'll discuss about chlorine, Cl2. For chlorine, use damp litmus paper. Litmus paper is bleached. So when the chlorine is present, the litmus paper turns bleach. If the litmus paper turns bleach, then the gas present is chlorine. So the test for the chlorine is use damp litmus paper, and the result is that litmus paper is bleached. For hydrogen, H2, use burning splinter. Use burning splinter. When the burning splinter is brought near to the hydrogen, we trap the hydrogen in a test tube and bring the burning splinter nearer to the hydrogen, the pop sound is produced. I can draw here how to test the hydrogen. For example, this is a test tube, and in it there is a hydrogen trapped, and this is a tube. This is a burning splinter. When this burning splinter is brought near to the hydrogen, the pop sound is produced. Pop sound is produced, mean you can listen a pop sound when the burning splinter is brought nearer to the hydrogen. So the test for the hydrogen is that use a burning splinter, and the result is that pop sound is produced. For oxygen, use a glowing splinter and splinter relights. Mean as in the hydrogen, you can take here O2, and when the O2 is trapped in a test tube and a glowing splinter is brought nearer to the test tube, nearer to the hydrogen, it would relight, mean the fire would relight, and we can detect that this gas is oxygen. So the test for oxygen is that use a glowing splinter, and the result is that splinter relights. So now we'll discuss about sulfur dioxide. For sulfur dioxide, SO2, use acidified potassium dichromate. Potassium dichromate. If the potassium dichromate is used to detect this sulfur dioxide, it will turn from yellow to green. If the potassium dichromate turns from yellow to green, means sulfur dioxide gas is present. So the test for the sulfur dioxide gas is that use acidified potassium dichromate, and the result is that the potassium dichromate turns from yellow to green. So this was the end of our class. We can have a short summary what we have discussed today. So first of all, we'll discuss what is a salt. A salt is a substance formed when the hydrogen of an acid is partially or completely replaced by a metal. Then we'll discuss about the identification of ions, and I tell you about the ionic bond. The ionic bond is the bond between a metal and a non-metal, and then I tell you that cations move to the cathode and anions move to the anode. Cations are negatively charged and cathode is negative. Cations are positively charged and anions are negatively charged. So the cations move to cathode and anions move to anode. Then we discuss about the test for the cations. In the cations, we discuss about the test for aluminium, calcium, copper, iron +2, iron 3 positive, and lead, zinc, ammonium. Then we'll discuss about the test for ammonium. Anions mean negative ions. For in anions, we discuss about nitrates, carbonates, chloride, carbonate, chloride, iodide, and sulfate. I tell you about sulfate, that add NOH and aluminium powder, ammonia gas is formed. Then we detect ammonia gas. And in carbonates, for the carbonates, add dilute hydrochloric acid, and I tell you that an observation carbon dioxide is formed. Then we detect carbon dioxide by lime water as it turns milky. Then we discuss about chloride. In chloride, we discuss add nitric acid, dilute nitric acid, and silver nitrate and white PPT form. In iodide, the yellow PPT form when dilute nitric acid and lead nitrate are added. And in sulfate, we discussed that dilute nitric acid and barium nitrate, and in observation that we discussed that white PPT form. Then we discuss the tests for the identification of gases. In gases, we discuss about ammonia, carbon dioxide, chlorine, hydrogen, oxygen, and sulfur dioxide. For ammonia, use damp red litmus paper. Litmus papers turn blue. For carbon dioxide, bubbling through the lime water, and the result is lime water turns milky. For chlorine, use damp litmus paper. Litmus is bleached. For hydrogen, uses burning splinter, pop sound is produced. For oxygen, we discussed that use a glowing splinter relights. And for sulfur dioxide, in the test we discussed that use acidified potassium dichromate, and result is that it turns from yellow to green. So this was the end of our class. I would be again with you with another interesting video.